Hello everyone, my name is Arunan, and today we're going to be doing some physics problems that include using one of the equations that does not involve the variable delta d in it. And that equation is the final velocity is equal to the initial velocity plus the acceleration times the change in time. Now, whenever you're doing a physics problem, it's always good to draw a mini diagram so you have a visual on what you're doing, and it makes it much more easier to do the problem. Now let's look at a problem. A car traveling on a straight road accelerates from 15 meters per second to 21 meters per second in 12 seconds. What was acceleration? So I just drew a little car right here, and it says that it accelerates on a straight road. So let's draw another car. I'm not an artist, as you can see. And it says that the initial velocity was 15 meters per second, and the final velocity was 21 meters per second. And the delta t equals to 12 seconds. So what I'm just going to do is underline all our givens. So that's our initial velocity, our final velocity, our change of time, and what we're trying to solve. So in our given section, I'm just going to write that in. So our VI equals to 15 meters per second. Our VF equals to 21 meters per second. And our delta t equals to 12 seconds. So now I'm going to use the equation VF equals to VI plus acceleration times delta t. And what I required was what the acceleration is. So now let's get to the solution. So I'm going to rewrite the equation again. VF equals to VI plus acceleration times delta t. Or VF, so let's first rearrange the equation. So VF minus VI over delta t will give us the acceleration. So the acceleration equals to 21 meters per second minus 15 meters per second over the time is 12 seconds. So let's do that now. So I don't know why this is getting blurry, but okay, there we go. Acceleration equals to 6 meters per second over 12 seconds. So our acceleration would equal to 1 over 2 meters per second squared. And if we want to look at significant digits, it would be 0.5 meters per second squared, because 2 significant, 2 significant, and 2 significant. So when you divide that, we take into account all those significant digits, and we're left with 2 significant digits as our final answers. So therefore, the acceleration of the car was 0.5 meters per second squared. So let's look at our second problem. It says an object is dropped from the top of a building. How fast was the object going at 1.5 seconds? So like I said before, I always draw a diagram. So it says that the object, so let's say it's a ball, is dropped at the top of a building, and we're not going to be taking into account any air resistance. So it says, because it says it's dropped, the v1, or the initial velocity, is equal to 0 meters per second. the time that they've given us is 1.5 seconds. And what other variable are there? Well, the variable that we're trying to solve is the final velocity, and we need acceleration, right? So they haven't set in the equation because we should know that this is a real world problem, which means that we're going to be taking into account gravity, and gravity is what our acceleration will be. So acceleration is going to be equal to negative 9.8 meters per second squared, which is a value for the gravity. So let's write in our givens. So our VI equals to 0 meters per second. Our delta T is equal to 1.5 seconds. Our final velocity is what we're trying to find. And our acceleration is equal to negative 9.8 meters per second squared. What's required, as I said, is our final velocity. And the formula that we're going to be using is Vf equals to Vi plus acceleration times delta T. So our solution is Vf equals to 0 meters per second plus bracket negative 9.8 meters per second squared times 1.5 seconds. So Vf equals to, we don't need this, so I'm going to get my calculator out and just multiply this in. So do negative 9.8 times 1.5, which gives us negative 14.7 meters per second, as one of these seconds will be cancelled. And when we were first doing this problem, the positive direction was up, and because this is negative, that means it's going the opposite direction. So our positive now is going down. So the positive value is down. So this used to be up. Now we're going to just flip it around so we can get rid of the negative. And so we get 14.7 meters per second down. And if you look at significant digits, we're going to have to round this to 2 significant digits. So that means because this is above 5, we can round this to 15 meters per second down. Therefore, the velocity at 1.5 seconds was 15 meters per second down.